Okay, so yeah, let's begin with lecture 12. This is about controlling loops. And in specific, we'll be talking about how to utilize for loops, while loops, to do tasks that are not quite evident when we look at them, because sometimes we want to control the way the loop is executed, right? We want to control the number of iterations. We want to control how it accesses an element in a list or a string and so on. So that's what the focus of today's lecture is. And we'll talk about like for loops, while loops, of course, and because while loops are important in controlling loops as such, because these are infinite loops, as we know, and so we need like different ways of controlling them. They might become like infinite in certain situations, and so there are ways to do that. And we'll talk about how to access list of lists using loops, and how is that different, and what are different like variants of using loops with list of lists. So that's the overall focus. Let's again begin with what we already did last time, which is using the range function with for loop. And that's because that review is important, because we'll be using that a lot today. So let's begin with that. And this is just like a recap of what we already know. So for some variable in range, and remember the syntax for the for loop was for variable in iterable, and range is an iterable. So for, let's say, range in 10, and then print I, right? And this I is essentially going to print all the numbers starting from 0, because I haven't specified the start, and it's going to stop like 1 before the range, right? So that's what we expected, and that's what we got. Now, similar to that, there are different parameters within the range function, and let's look at it like using by converting it to a list, so that we know what values is it generating. Now range, if you remember, we said the default is that you just like give one parameter, and that's going to be taken as the stop value. But the overall syntax for range is this. The range is start, stop, and it stops 1 before whatever stop you're providing. So it will be like stop plus 1 should be the value that you should provide, and then step. All right, so let's look at a few examples again. And so one example is like start at 3, end at 7. So if we want to end at 7, I'll end at 8. Okay, so I wanted to start at 3, end at 7, right? Another one could be, again, list range. Let's say I want to begin at 4 and end somewhere at 20, so 21. And I also want to jump by 3 values. So what I want to do is like 4 plus 3, that's 7, and so on, right? So then I can specify the step size. Let's see what happens, right? So I'll begin at 4, 7, 10, 13, 16, and 19, of course, because my max is 21, and if I add 19 plus 3, that's 22, so it's going to go beyond that range, and it stops there. But that's the most like general form of the range function. We can always also generate like a backward list, like backward range of numbers. Let's look at one example again. And you can tell because we've done that before with lists, but still it's similar to that, like we were doing with the slicing operator. It's similar to that in the sense that, let's say I began with the last element, right? That's like, or maybe I'm saying like begin with -1 and go up to some -10, right? So this is not like the index. That's what I'm trying to say. This is the number. And so I'm saying like keep adding like -1 to this -1. So basically -1, -2, -3, and so on. So let's look at that. Right, it'll go up to -10, but not include -10, because that's how the range function works. So we can print like backward range of numbers, forward range of numbers with certain like steps within them, and so on. So this is like very flexible and quite useful, especially when we're working with for loops. And it gives us like the flexibility to print like these different range of numbers that are required when controlling loops. So that's the fundamental idea. Let's look at this example. I think it's in the lecture notes. We talked about the increments. We can do decrements just like we did in this example. Yeah, this example here where we have this list of planets. And let me show you 2 things about this. All right. So usually we want to access every element of a list and do something with it. So let's see how we can. Sorry, was that? Can you guys hear me?
Yes, it sounded like it came from you.
Okay. Yeah, I request everybody to mute their microphones, and if they have like questions or anything, just like feel free to type in the chat, because it might become chaotic at times because we're like so many of us there, right? The number is huge, and yeah. All right. So going back to accessing the elements of a list. So there are two ways. Let's say if I'm saying for I in planets, right? So for I in planets, print I, right? So if I'm saying something like this means for variable, like just like we did last time, right? So this is going to print the actual elements, right? Let me do this. And it prints the actual elements. But if I do something like this, for I in range len of planets. Now, range, as we talked about last time as well, that this is going to take care of the fact that my list is like one less than length of the planets because it doesn't take that last element, right? And if I do something like this and print this, let's see, right? I'm getting these indices and not the elements. So if I need like these like elements instead of these indices, and I have like this for I in range, because range is uh, generating these values, these numbers, and not the actual elements that are there in the list. So all I have to do is like specify the name of the list and then index it, right? Because I know that these are the indices and I can pick them up. So this is like another way of using lists with for loops. And I can actually pick the elements. Now, why is this like so important? This is important because when we start using loops with lists, especially for loops with lists, and we see that there is this like flexibility that is offered by the range function many times when we are trying to control things, right? And so like we forget that when we say for I in list versus for I in range length of list is like that these are two different things that we are doing, right? And so be like careful when you're trying to pick the element versus when you are trying to actually get like the index of that. All right. I think we have a few practice. We already did this, like print the indices starting at 1, so that's fine. How about we try doing this one? Print the planets backwards. How can we do that using this like for I in range? What exactly do we need to change here to print them backwards? So remember, this is the index, the I, yeah. So Ilyana, you're saying print minus I here. I don't think that's going to work because what does minus I means? I is just a local variable here, right? Yeah, start exactly. Linus, I think you said, yeah, okay. You're saying begin at -1, so that makes sense, yeah. I think I thought you're saying index at like -1, that's my bad. Okay, so begin at -1, excellent, as all of you pointed rightly. And then step down, right, by -1, that's also fine. What do you think, where should we end at? Should we end at like len planets? Or should we do something here? What exact update should we do for the second parameter in the range function? Let me see, I think somebody, what should we do for the second element? Like where should we stop is my question maybe. So how about we do like a minus len planets, but then let's see what this does. So, okay, so like this, the stop, now the range function takes in the numbers, right? So if I'm doing a minus len planets, that's going to be like the negative of like whatever values are there, right? And okay, Linus, you're pointing out, what if we say 0? And that kind of is logical because we're saying stop at 0, like start from -1. So, but then that is just like one iteration because it's going to just um, stop there. And so how about like take the length of the planets -1, right? Because that's the number of indices. Okay, let's try this. I just added a negative here and see what's wrong, and then we can like update and see what's going on. Right, so it started from Pluto, went until Venus, and it missed Mercury, which was expected because there is one more after that. Because I'm taking this like length of planets, and the range function stops 1 earlier. So I will also do a -1 here. Let's try this and see why this works. Right, so now this one has all my planets. So what this is like demonstrating, this particular example, is that like a slight variation in the range value parameters can help us get the list values or the list elements in a different way. And this is something that will be the focus, I would say, of the homework that's coming up, that how can you use lists, how can you use loops to control elements maybe in a list or a tuple or whatever you're working with. Because here we didn't want like Mercury to be printed first, but rather Pluto to be printed first. And so this is the update that we can do. Okay, let's look at another variation. How about, I don't want to print all the planets, but I want to print like Mercury and then Earth, like jump by 1. So then what should I do? Of course, begin from the first one. And what else should I do here and here? Step, Miriam, yes, step 2. So because we want to jump, right? And I think the second one, should it be alien of planets or no? Well, we don't care, right? It is going to like take and like start taking from 0 and add 2 to it. And if like the last element is included, that's fine. If not, then let's not include it, right? So let's see if we can do that. Right, so Mercury, Earth, Jupiter, Uranus, and then Pluto. So that's okay, right? This is what we wanted. Now again, demonstrating that we wanted to, although we wanted to get elements from this list, but not like all of them. So we can like update the range function in the way we want it to work, just like we did with like the reverse list. And now we're doing it with like every alternate element, not every element, but like skip 1. All right, so the concept still stays the same. We know how the range function works, except that like we are using it for a list. And the best way to do that is to use the indices of the list and then use like the name of the list and the index. So that helps get whatever we want to get. All right, so that was the like using range in for loops. The next section is about loops. Okay, there was a question, and that it's a good question, John. If the step is greater than the stop, does it print nothing? So step is greater than stop. You mean that, let's say the length of the planets is like 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 10, right? And so this is going to add 10 to it, which does not exist in my list. And let's see what this prints. And as you rightly said, it's going to, okay, this has to be 11 because it's still printing the 0th. Okay. So this is like an excellent example, and that's an excellent question because I'm beginning at 0 and I wanted to like definitely take that particular element and then take a step like of size 11. So when I take a size of step 11, I don't see any other element falling in that. But 0 was still printed because it began with 0 and 0 is inclusive. So let's say if I begin at 1 and then take a step size of like this thing, then it's going to still take this 1 and then see like what's the next element. So that's a very good question actually, because the first one would still be printed, right? Whatever the index I'm providing there would still be printed. Now it depends on like maybe I started at 10 or maybe I started at length of planets, then nothing would be printed. That's a very important and very good question. All right, any other questions before we move on? Okay, let's move on. Oh yeah, this is again an important one. And so I'm going to take this here. What the problem we are looking at is like, this is an example that we looked at in lecture 1 as well. And at that point in time, we didn't understand everything, but now we understand every part of this code. So what the problem was, is given a string or given like some word, what you have to figure out is, can we find the words that have like 3 consecutive double letters? So let me write it down, what we're trying to do here. Okay. Okay. So let me assume this S is like some like X, Y, A, B, B, C, C, Z, right? This is a string. And so I have like 3 consecutive double letters. If my S is something like, again, X, Y, Y, and then A, B, B, C, C, then I should return a false for this one. So they have to be like double letters and consecutive. Now, this is not consecutive because there is like an A there, although we have like 3 double letters, Y, Y, B, B, and C, C, right? So we don't want this. We want something like this. So this is the problem that's asking us to go and like take this string and then scan through that string and find if this is the case, then return a true, right? And if this is a case, then return a false. All right. So we know how to scan through a string. We can do indexing, just like we doing indexing with using loops with lists. So similar to that, we can do with strings. And I want to go over what's like going on and how can we control the execution of this one. Now, let me just copy it in Spider. Okay. Okay. So I know that what I'm doing is like in a given string. Let me again write it down because that makes things easier. So in any string S, look at the if statement, right? So when my S is like, as I said, A, B, B, C, C, right? I'm going to pick the first element, which is like, so I'm going to loop starting from like index I, which is going to be 0. So I'm going to check what's at position I, and then I'm going to check what is at position I plus 1 and see the relationship between them. If they're equal, then yeah, keep going. And then I'm going to check the relationship between I plus 2 and I plus 3. And if they are equal, then keep going. And then I'm going to check I plus 4 and I plus 5. All right. Now, if I do something like for, like notice the for loop, right? If I do something like for I in range, and forget about this. If I do something like for I in range 0 to len of s, do you think this execution will go fine? Yes or no? What can happen? What can go wrong? Excellent. Yeah. Because you've been using this Brook, what you said is right. So eventually, if I do for I in range 0 to length of s, that means go and scan every element in this, right? And so the moment it comes to a position where one of these indices, like I plus 5, I plus 4, or I plus 3, or I plus 2 does not exist. So for instance, let's say I am at position B, right? And this is going to be my I at some iteration, right? And so of course, I plus 1 exists, which is this B. I plus 2 also exists. I plus 3 also exists, but there is no I plus 4 and I plus 5. And so I'm going to get this error index out of range. But now my problem is that I need to figure these I's as well, because my string could look something like this, right? X, Y, Z, B, B, C, C, D, D, and then again X, Y, Z, L, M, right? It could be something like this. And so I need to figure that out in like a single iteration. So what can I do? So one way is that I know that the length that I'm looking at is of size 6, right? At least size 6. So if I'm like looking at some huge string and like there are only 5 elements left, right? There is no way I can like find these 3 consecutive double letters. So I can just like make my loop stop at that point. So it won't go out of range because those elements will exist, like I plus 4 and I plus 5 will exist. And I would have tested that, you know, those are not equal or something is there. And so I don't need to go there. I don't need to make any of these last 5 elements as my I anymore. All right. So that's what this is doing. This is how we are controlling this loop. And one additional point is like also look at when we kind of control our loop, thinking about the indices that I'm going to access in a certain iteration, I'm also restricting my iterations. How? Because if I have like a string that is of size 6, right? Let's say this is A, B, B, C, C. This is size 6. This loop will execute only like one time. That's all it needs instead of like 6 iterations. So I'm like saving time as well because that's what I need to do. It just executes one time. And then if it's like 7, so then it's going to be like 7 minus 2. So it won't iterate more than 2 times and so on. So I'm like also restricting in this sense the number of times my for loop executes, right? So let's look at what's going on here. All I'm doing is, as I said, have restricted it because I don't want to go beyond like I don't want to go into the last 5 elements. And also this will also take care of one more corner case, I would say, another test case, which we also call test case. What if like the length of my string is 4? What if the length of my string is 4? So I don't want to like even go and check for these conditions, and it just like, yeah, it turns false. Excellent, Austin, that's right. So then that's also another case that like just by controlling the range, I can take care of all those cases, right? So let's run this once and like do some testing with some strings. So let me create the function, and this is like has 3 doubles, and let me give it a string, right? So x, y, a. All right. So this definitely returns a true because it has like these consecutive double letters. What if I include something like this? It should return a false. If I'm giving it something like this, there is no way like in like a something that's less than 6, size 6, you're going to find 3 consecutive double letters. So we are controlling all of those cases just by adjusting something in my range function. So that's exactly what this example is demonstrating. All right. Questions, doubts about how we did this? Now this should be clear, the if statement, right? We need ands because like if any one of those conditions does not hold, then we want to return a false, right? So that's why we are just returning a true when all of these cases are true, and you know what and means? It means all of them need to be true. Okay, let me see if there are questions. Yes, Austin, that's right. It won't. No, so it's not length 6 string. It will work for any string that's 6 or greater, right? No, it will work with the longer ones. I'm not, of course it has to work with the longer ones. Otherwise there's no point, right? It has to work with the longer ones. But what's going on here is that I don't want my iteration, I don't want my I to go until the last element. Because if it goes until, or maybe I don't want my I to go to a certain element that such that in my string this I plus 5 does not exist. And so that's how I'm restricting it. Yeah, you can copy it from the, like if it's not working for you, you can copy it from the course website. I already posted the code. John, you're saying if you put a not in front of the if statements. So if you put a not, it's going to invert like one of them. So if you want to like invert the entire thing, then you have to put them in brackets, and then that's going to invert that. Yeah. Yeah. All right. Okay, so if those are all the questions, then let's move on. I think we have some practice problems. Oh, Miriam, I saw your question disappeared. I'm confused how this worked when I0 is not equal to I1. I0, I'm not sure what exactly you're saying when I0. Yeah, so we are going to check for like so this loop is going to execute as long as I've not exhausted my string, right? Okay, let me explain again. I think, no, I think you were not getting it right. It has nothing to do with the 0. I think I have to explain it again. That's not the point. The point is go and scan a string that's of size S, right? So let's see what's going to happen in this particular case. It's going to come here, right? So my I is going to be 0, and it's going to check this 0 is not equal to 1, because this is like I plus 1. X is not equal to Y. So that's fine. Go and don't do anything. Because why? Because my for loop still has to iterate, because what is this? This is length of the string 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 minus 5. So that means I still have to go and iterate 4 times. My loop is not going to stop yet. Because this return false will happen only when my loop has exhausted. And then, because you can see this is outside the for loop, not inside. So it's not like against my if statement. Does that make sense, Miriam? Yeah, because like that's why I said we are not just like checking these i's and like stopping it at the right time, but we are also controlling the number of iterations my for loop is going to take. Because if this string is of size 9, then at least it has to iterate for 4 times and then check, because maybe this like I equals I plus 1 plus I plus 2 can exist somewhere else, which was the case here. So we cannot just like discount the fact that it can. What was the question, Caesar? It wouldn't work if length of S was less than 5, right? No, it would work. It's just that I'll skip all the iterations because there is no iteration to go into. And so I'll just return a false. For example, let's say this, right? And so it would just return a false. Huey, your question is, how does the return true overrides the false? It does not. It does not. Where exactly is the true overwriting the false? This true, there is just if statement inside the for loop, right? And so this if statement will be tested for every iteration of my for loop. So this true is not overwriting anything. It's just that if my loop doesn't enter into an iteration, I'm going to return a false. That's it. It doesn't enter into that iteration. Or if like this wasn't true for any of the iterations, then I'm finally going to return a false. Otherwise, whenever this is true, I'll return a true and end of my function. Does that make sense, Huey? Yeah, I mean, I think all of you are focusing more on the if statement and like less on the iteration part, because this condition will be tested for every iteration. So we also have to see how many iterations are possible for a particular length string. Okay, so okay, Huey, that's a very basic, like if the return statement has been executed, it will just be executed. That's it. It comes out. Return means come out of the function, right? That's it. Return a false or return a true. It cannot return both because a function just returns one value. So it will just like return whatever it encounters first. Okay. I think those are all the questions. Let's move on to the practice problems. And if you have more questions, you can type in. It's not a problem. Okay, so let's look at let's read through these, and if they're like easy ones, we can just skip them, talk through the solution, and then move on. And if there is something that we feel that we should be doing, then we can do that. So generate a range for positive integers less than 100, so which means starting from 1 and going up to 100. And then use this to calculate the sum of these values with and without the use of sum function. So well, with the sum function, we can do sum range 100, right? All the positive values from less than 100 means like 99. And like, you know how to use that in a loop, right? So I'll just like skip this one. This is not that hard. Let's look at this one. Use a range and a for loop to print positive even numbers less than the integer value associated with n. Okay, so maybe this is also straightforward, but let's quickly look at it. Let's say my n is, I don't know, 90, right? And I want to print everything less than 90 and starting from 0 and then skip by 2. Right? So that's okay for I in range 0 to n, less than n. So I'll just write n and then skip by 2, right? And print I. Okay, let me make it smaller because I know this is going to go on and on. So yeah, this is how I think we did that example earlier as well. All right, this one is interesting. Suppose we want a list of squares of digits 0 to 9, and this is not going to work. Why and what update can we do here to get a list of the squares of digits like starting from 0 up to 9? So what we want is like 0 and then 4, 9, and so on. Let's see. How can we do that? Okay, so this definitely won't work because we are just like updating. If you look at it, we're just updating the like the variable for my loop, which doesn't really help. So what should we be doing? I think I saw Austin, you said, can we just put the for loop in the list? For loop in the list. Okay, you mean another list, right? I think yes, that would be it. We can put it in another, like have a new list and then put these values in that. So that's of course a solution. I think this is what you're saying, right? And then instead of like squaring them here, what I can do is like just append the squares to this one, right? So I can just like say final dot append. But what should I append here? I'm saying for s in squares, and squares is like all these numbers from like 0 to 9, right? So I want like, what should I do here? How do I get the square of all the numbers here? Yeah. Okay, so what we can do is just like the square of each s, right? And then just like append it to that, because like this list range already has like every element. So I'm just like squaring every element and then printing my final list. Okay, so that was that. All right, this is interesting because this is built on what we did for like this example here, 3 consecutive double letters. Instead of that, we are trying to find 2 consecutive double letters. So what exactly should we update in our code? Of course, the if statement should be updated, right? But then it goes back to a discussion of like the number of times my loop should be executed, because it depends on the length of my list, right? So if I'm trying to find 2 consecutive double letters instead of 3, what exactly should I update in this, apart from the if statement, which is already updated? What exactly should I update? Because let's look at this example. All right, Luke, Eliana, you're saying, Luke, you're right. Length of S minus 3, Rochelle, you're also right. Caesar, everybody's right. Instead of like, because we have to consider how many iterations do we want, right? Given like length, of course, I want to skip everything that's like less than size 4, because that doesn't make sense. But then I have to be careful about like long lists, strings, such that I can find 4 consecutive, like 2 consecutive double letters anywhere. That's what the point is. So let me show you what this means. Has 2 doubles and then, well, x, x, y, y. And it should work now because we just updated that minus 3. If we had not updated that, then what will happen is, let me show you. This is going to return a false because it's less than that, right? So then that wasn't correct. Although we updated our if statement because we just wanted to check like 2 times this consecutive double letters and not like 3 times. But here we forgot to check the number of iterations of my loop. And so that's why I have to be careful about that. Because if there are like, think about it, if there are only 3 characters in my string that are left to be like scanned, and I haven't found like one of them equal, then I don't need to go and scan anymore, right? Because there is no way I can find like 4 letters that are like consecutive in this sense. So that's the idea there. All right, the second part of today's lecture is nested loops. And nested loops are extremely useful. We've looked at them before, but today we are also going to use them to understand how can we use list of lists with nested loops. So let's look at them. And this is just like from the previous lecture, similar to that. I think we used it with the while loops, right? Not exactly like this. So now we are looking at for loops. All right, so digits is nothing but like range of numbers up to 10. And then what I'm doing in the outer loop, the control is the same like we did with the while loops, remember? The outer one is going to execute for every value of I, and then that is going to go into the inner loop until the inner loop is exhausted. The idea is again the same, and let's see how that is going on. So this is like I and j for every I starting from 0 up to 9. Every j will be printed, and then their obviously their product will be printed until this like inner loop is exhausted. And then we move out and we see that I is not exhausted yet, because then it'll start from I don't know, 0, and then it will go to 1, 2, 3, and so on up to 9. So it's the same thing here as with the while loops. Let's quickly look at this. So basically what it's doing is it's like printing these values, like multiplying every digit with the other one. And as you can see, the outer loop begins at 0, and then it gets exhausted for every element until 9. So the second element is j, right? That's why we have this particular example here. The second element is j, so you can just tell by looking at the output how the execution is happening. And again, similar to the while loop, but the good thing here is that I don't have to worry about updating these i's and j's. All right. But again, I can control like what I want to control in the inner loop, or I can control what I want to control in the outer loop, just like we did with the earlier example, right? So all of that applies here as well. Okay, so let me go back and see. Yeah, this is a nice example to kind of demonstrate the use of nested loops, especially when using lists. So whenever you see this kind of structure, for example, here we have these points. So these are like in 2-dimension, like x, y. So x1, y1, x2, y2, and so on. And so this is a list of tuples, right? Whenever you look at this kind of a structure where you have list of lists, list of tuples, the first thing that should come to your mind is to access these elements within these like inner structures. Usually we need loops, right? Or sometimes even like nested loops. Most of the times I would say nested loops, because that's how we can access the elements within. All right, so here this problem is asking us to find 2 points that are closest to each other. So what do you mean by closest? So in closest, we are trying to find the distance between each of these points. So essentially we'll be finding distance between every pair of points and finding the one that has like the minimum distance. You can tell that we have to scan through like every element. That means nested loops. Okay, so there could be 2 approaches of looking at this problem. First could be to go and like scan through every element, find every possible distance between all these points, and then put them in a list and find the minimum, right? That could be the like approach number 1. Approach number 2 could be similar to what we saw in another example earlier, remember? And that like these are 2 like standard approaches of like finding the closest or the farthest points in a list of tuples. The second approach is you assume, like you initialize that the first 2 points, we assume that these are the nearest points, these are the closest points, right? And then we start scanning through the rest of the list and see if we find anything that's like better than this. And if we do, then we update this, right? So let's look at both the approaches. And the way we are like trying to do all of this is that have a function that calculates the distance between any 2 points, because we'll need that, right? And then use that function to find the closest points as and when we want. Okay, so let me begin with that. This function we need in both approaches, right? Because I need some functionality that is going to find the distance between any 2 given tuples, essentially, right? So I'm naming it distance, and the input is like 0.1 and 0.2, assuming that these are going to be some tuples based on my input, right? And what I want to return is, and of course you can use math in this as well. This is just like the most basic way of doing it. Here we need the square root, so 0.5. Recommended would be like to use math like sqrt, but I'm just not doing that for now. P1 of 1, y, the first element of my tuple 1, right? Square it, like find the difference and then square it, right? So P1 minus P2, the first element again, x1, x2, and just square it. And this is just like the formula, right? Oh, I think I wrote it right. All right, yeah, looks okay to me. If there is something wrong, please feel free to point that out. And of course, the 0, that means the y's. So the y's and the x's essentially. Quickly, no syntax error, so that should be okay because of the number of parentheses. All right, so this is something that we'll be using for either of our approaches. The first approach is that you go and iterate over this entire list, right? Let me go and pick this up from here. That will make things clear. Miriam, your question is, what is J? Was it from the previous one? Yeah, J is for the inner loop, right? We need like 2 indices to figure that out. And the second question is, shouldn't it be 0? Oh, you're saying that's fine? Yeah, because like my tuple has two elements, right? So 1 and 1 and 0 and 0. All right, that's fine. So this is my distance one, and as I said, we'll have like 2 approaches to solve this problem. So the first one is, and I'm naming that function closest, maybe dist1, right? And then the other one would be dist2. In this one, I'm going to iterate over this entire points list, right? And then what I'm going to do is pick every pair, find the distance, and put it in some list, and then figure out the minimum of them, and then like output that, right? So let's do that. This is like a very straightforward one. Sometimes it's like slows down the code, and we'll talk about that later, so we don't have to like worry about that yet. For I in range, and then this is called points, right? So length of points. Okay, so I is going to pick every like tuple. Sorry, I is the index for that. No, so it's not going to pick tuples. I'm going to access them using like point I and point j, like that. All right. So for I in range, length of points, which is my list, and inside for j in range. Okay, so here's the thing. I don't want like my I and j to pick the same point, which is like 1, 5 and 1, 5 again, because there is no point in doing that. So let me begin like one more than whatever my I is all the time, right? So I can do some kind of like tweaking here. So let's begin with I plus 1 and then do len of points. Of course, you cannot go beyond that. So that's fine, right? Now all I have to do is like in my dist list, right? Just go and append the distance between like point I and point j, and also if we want the indices. Let's say I wanted not just like what is the minimum distance, but also what is the position of those points that have the minimum distance. Okay, so that's what I'm going to do. I'm essentially going to produce a list of lists. So be a little careful what I'm doing. I'm doing dist.append. And notice I'm not just like putting directly like this distance function there, but I'm also putting this list. So whenever I do that to an append, that means it's creating a list of lists. Always like remember that. So what I'm doing is, because I also want the indices, right? So I'm just saying distance, which is nothing but my function, right? And then the function takes tuples, remember? So how can I specify the tuples? I can say points I and points j, right? So this is this, and also I want to keep track of like my indices, points I and j. That's it, right? And now this is going to produce a list of lists for every like pair of distance and the indices, the corresponding indices. But I want the minimum distance. I don't want anything else. So what will I do? I should just return, and again, pay attention to this one. If I'm doing something like this, min dist, let me first demonstrate this before even running the code. Let's say I have this list L, and it has, let's say, I don't know, 1, not 1, 5, and 6, right? These are list of lists. And the other one is like 1 and 3, right? And let me just create it. Now, if I'm doing like a min of L, you might say, what exactly is it going to find out? Like, what is the min of L? So what it checks is like the very first element. So it's based off of the very first element. Let's see what it does. Right, it returns this element that has like a smaller first element as compared to the first element of this one. So that's exactly what I'm doing. When I do a min of dist, this will have like these sublists, or like, yeah, sublists that have like the distance that's returned from this function and the i's and the j's. So then i's and the j's weren't like the first two elements. And so it's going to find the minimum distance and not like the minimum I and j. That's why this min dist will work. All right. So that's that. And let's just run it, because like the second approach is, I would say, very similar to what like something that we did, and we will just go over the code, but I wouldn't or maybe we can write it. I think we have time. So let's run this first. Let me show you what this returns, because that's important. Dist1, and we just want points. All right, and a more logical way would be to have the input somewhere here, right? And of course, below the guard and all of that. I'm skipping all of that. Let's see what this returns, this thing here, closest points. Now, notice what this has returned, right? That sublist that has the minimum distance, and that's at index 2 and 3, which is 0, 1, 2. So the distance between points 2 and 3, which is like 10, 5, and 8, 2 is the minimum. But let's say I just wanted to print that like only the distance of that, right? So what I can do is I can just like say print the element at position 0, right? So sorry, not like this. This is returning the sublist, so I just want like the element at position 0, right? Or another way could be to save it in some variable, this entire sublist, right? And then print x at position 0, because let's say I only want the distance, right? So if I do that, right, so it will only print this distance. Or maybe I just wanted the indices, right? So I'll just like go and print x1 and x2, because I only want the indices of the points that are nearest. So it's going to print like 2 and 3. And of course, you can have like a nice print statement saying this point is nearest to this point and so on. All right. So this was about this. Any questions, doubts about this part? Let me grab water. Okay, I don't see any questions, so most likely everybody's okay. Lauren, your question is, why would you not print x0? Well, I would definitely print if I need. I was just like showing what all possibilities are there, right? If I want to print, I can definitely print. This was the nearest distance, right? I was just showing how we can print different elements in that sublist. Yeah. And that's all good. Like, please keep asking questions. It always makes it more, I would say, relatable. And the other approach that we're looking at is, and again, we've looked at it before, but I'm emphasizing it a lot because it helps whenever you see these type of questions where you have like list of lists or list of tuples, and I'm asking you to find like the nearest point or the farthest point, right? So these are the two approaches that mostly work. So let's look at the other one. Define closest points, or let me be consistent, dist2, right? And then points. All right, so in the second approach, I'm assuming that the first 2 points are the smallest. And so that's like an initialization, right? The smallest is, or maybe it's just small, is distance, which is my distance function. Maybe it's gone here. This distance function, right? And the first 2 points in my points list. So the first 2 points are points indexed at 0, right? And points indexed at 1. So this is like, I'm assuming that this is the nearest distance, and I'm just like putting it in a variable called small. And I also need to track my indices, right? So I'm saying I1 equals 0 and I2 equals 1. That's it. Now I'll go through this points list again, similar to what we did here. I'm going to do a similar thing here. And so let me just like copy this here, except that I'm going to check for certain conditions. Let me do that. So for I in range length of points, that means like go through this entire list. And then J is like go through this entire list again, but start from the next point, not from the same point, because obviously the same point is going to give me 0, which is going to be minimum. And so that is going to be a semantic error, right? Now, once I'm inside my loop, because I'm accessing 2 elements in this like at the same time, let me create this temporary variable dist that will again call the function distance, but with the different argument. right? So it is going to have like points I, and that's what it takes, right? Points j. Let me see, this is, okay, that's fine, right? And if this distance, if I found a distance that's smaller than my small, right? I found a distance that's smaller than the small that I initially started with, then I'm good. What I have to do is update my small with this dist and also update my indices with I and j, because these are going to be my indices now. Why is it giving me this? Okay, we are going to use that. So let's come out of the loop and as usual return small I1, I2. Now it's up to you, how do you want to return this? Whenever we are returning multiple elements on the same line, if you remember, this is going to return a tuple, right? And let's first run this and then come back. Okay, so what I'm going to do here is repeat this entire thing, but with different values. For example, this is going to be dist2, right? The name of the function is dist2, and let me name it y just to be. Now again, I can access my y. This let me just print y. Let me just print y. Okay, let's do this. Right, so this is again, this is returning a tuple instead of like a list of lists. So if I'm printing y, and let's say I only want the indices, not like everything here. So again, I can just like go ahead and do whatever I want to do. Or if I just want the distance, I can access that like outcome of my function as like y0, y1, and y2, right? So let's say I only wanted the distance, or I only wanted like this. So it's up to me how I want them to like I want to capture the output. So that's the two approaches that we wanted to look at when trying to find two smallest or closest points in a given list of tuples. And this applies, by the way, to every such problem. It could be a string problem, it could be a list problem. You can always look at these two approaches and like try to apply them with like whatever the relevant modifications. All right, so okay, if there are any questions, feel free to, again, I'm repeating, type in. Let me move on and see if I left something. Okay, we looked at the two, and of course, like a better version is like posted on the course website as usual, so you can go and check that. All right, coming to lists of lists and problems surrounding like lists of lists as such. So this list of lists, and let's take it to Spider first. Okay, so this list of lists has captured data from like 5 different sites. So these are temperature that are taken at 1, 2, 4 different sites, not 5. And each one has like some temperature measurement. Okay, so let us assume the problem is asking us to go and check the average temperature and find the site with the maximum average temperature. Okay, so each of the sublists, first of all, is a site, right? And we know how to calculate the average. I'm going to sum them up and find the length of the sublist, and that's it. Okay, all of that is fine. But then additionally, I have to go and compare the outcome of each of these sublists and somehow come up with like which of these lists has the highest average. So how can we solve those type of problems? Let's look at this. And I'm using this, and I'm like, I would say capturing the average of every site in a new list, and then maybe trying to find the average, like the max out of that list. So that list, I'm naming it as averages. And this is an empty list, of course. And let's like iterate over temps at sites. Okay, so for variable in iterable, which is my list this time, temps at sites. All right, so I'm not using like in range lengths. That means this is going to pick the elements in my temp at sites. And what are the elements in like temp at sites? What are the elements of this list? Temps at sites. Yes, it is a list, right? It's an entire list and not any of these elements here. So that makes my life easier because that's what I I want to do. I want to just like sum that element, which is a list in itself, and find the length of that element and then put it in my averages, right? So let's say I have this temporary variable which is calculating the average. So sum of site, because that variable will have that list, and then len of site, right? We are going to have that, and then just like go and append it to the averages dot append, and then put this average here. All right. Now, once I have this averages list, let me just like first have this averages list here. Okay. Let's first print this, and then we'll like try to figure out how to find the max. So of course, yeah, and you can round it or like whatever methods we know, we can have them in a better form. But regardless, we are interested in finding like the maximum temperature. What is the maximum temperature in the list? And what site has that? Now, the good thing is that we have this list that we are working with, that's averages, and I can utilize that to find the site, because this, like these values got appended in the same sequence as the sites. And these sites are numbered like starting from 0, 1, 2, 3. So the site is the same thing as the index of like my list, right? So I can utilize that and find like whatever is the maximum average, which is like max, and I'm saving it in a variable average, which is going to be the max of averages, right? And once I have this, I can just like go and find the index of that. So my max index is going to be averages dot index, the method dot index. And what should I find the index of? I'll go and find the index of this max average, right? And then just like go and print your max underscore average and also the max index. Okay, let's do this. Okay, so of course it was evident that the site number 1 has the max average, and of course the site is 1 because we're counting from 0. It could have been like some other way. That's, let's say we were counting from 1, then you could have just like added 1 to every outcome, like output you got from this like dot index. Okay, questions, doubts? All right, I don't see any questions, so that's fine. Let's move on to another very important aspect of loops, which is like these control statements and these explicit control statements. And these are like really useful. Let's see how we can, in addition to whatever we know, how can we control our loops? And so we're talking about like these two new, Lauren, your questions, how would you add 1 to index without changing the index? Well, I wouldn't add 1 to my index. The way dot index works is it's going to find the index of like whatever element you've provided here. And so what I was saying was, if the problem is saying that the sites are numbered from 1 and not 0, so what you can do is just go and add a 1 to your max index variable. Okay. Going back to the controlling execution of loops. So these are two different programming constructs that we haven't seen before. One is the break statement, and the other one is the continue statements. How can we use them with loops? Let's look at an example with a while loop and try to understand how this works. All right. So what I'm doing is I'm writing this example wherein this like infinite while loop runs, and we want it to stop if the user enters like the number 0. Otherwise, we want it to keep like going on. And until the user enters a 0, I have to sum up all the numbers and print that number once the loop stops. Okay. So of course, I have this accumulator variable sum equals 0, and it's not a good thing to use sum because it's also uh, like an existing built-in function. So it's not a good practice to use that, although we can. Now notice this, like this very dangerous, I would say, while true. Whenever you say while true, this means it is an infinite loop. It's going to run forever. Now, in cases like this, when we have a certain criteria or a certain condition when we want our loop to stop, there are ways of like stopping this infinite loop. Let's see how that happens. So I'm reading user input as an integer and asking the user to enter an integer. Enter an integer. Okay, that's enough. And what I'm doing is, like every time someone enters this value, if this value is 0, then I want this loop to stop. Otherwise, I want it to like go on. So what I can do is, in this situation, there is no way to stop this loop because while true is like always true. It's not some variable or some flag that I can go and um, make false. So of course, that's another way of like stopping or controlling loops. And you know that technique already, where you can like convert it to like a variable or flag and then make it go false. However, in this case, let's say this is an infinite loop, or you know some condition that is going to take your loop into an infinite loop. What you can do is, if x equals 0, so whenever somebody entered a like value 0, just use this term break. Now, what is the significance of this break here? What it will do is it's going to stop the execution of your current loop, which is like my while loop. So it's going to just break there as soon as we enter a number that's equal to 0. So this is helpful when we want, like, no matter what, if this condition holds, just stop the loop there. And it is going to, by the way, skip like whatever values you have like below this if. So for instance, I'm doing this sum1 plus equals x here, right? And as long as I'm entering my x, like some positive values, of course it's going to come here because x is not 0. But eventually it's going to just like break. The moment it breaks, it won't like skips the rest of the loop. It just like stops the execution there, then and there. And then we can have print sum. So it's going to print whatever you have in like sum1. Let's look at it, how this works. So let me begin running it. It's an infinite loop. You can tell just by looking at the console here. So I'm entering 7, 8, 9, 2, 0. So now it just like stopped because it encountered 0. And so it is already like, there is no need to add 0, of course, to sum. So that's fine. And then it just like skips this entire execution of the loop and prints whatever, like, or executes whatever is right outside my while loop. So this is the break statement. It immediately stops the execution of the current loop. All right. Now, I think this is the same example. And like internally, it sends the flow of control immediately to the first line of code outside your current loop. So this is something that helps like stop your loop if you're suspicious or if you feel that this is where you just like want your loop to just stop and not do anything. So that's where we can control it by using the break statement. The other one, I would say that the continue one is, I mean, there are ways to kind of, um, and both with the break statement and the continue statement, these are like optional tools that you have. There is always some other logic that you can use to stop your loop, right? So these are like optional tools that you have. If you feel comfortable, use them. But there is always some other logic available that can accomplish what break and continue are accomplishing essentially. John, your question is, if you had the break statement x2, for example, would it still add the no? So it would skip that, right? So here we put this, that's an excellent question. So if we put this sum plus equals x, because obviously it doesn't matter if I add a 0 or not. But if you want that to be included, have the sum plus 1 like before that. Because what it'll do is it's going to skip this loop and just like print this. That's what break does. Sorry. Yeah, that's a good question. And also, if there was like a loop outside, so what happens when there's a nested loop and you have a break statement inside? Can anybody guess what happens if I have like another, like there is a nested loop, so there is another while outside this, and I have a break in the internal loop. So will it break? My question is, will it break the outer loop or not? Yeah, whoever is saying it breaks only the inside loop, that's correct. So what break does is it's going to break the execution of the current loop and not the outer loop. So you need another break for that one if you want that also to break. So you have to like have another break outside. Because the way it works is it's going to check the current loop and going to just like stop the execution of that. And if there is another loop outside, it's going to execute that. All right, so let's move on to this like continue. I just saw a question disappeared. Lauren, could you please do an example of a break with a nested loop? Yeah, that's a good one. If we have time left at the end, I can do, but I usually leave it to the students in every lecture to kind of go and try that themselves, both the break and the continue. So that is something that I would like everybody to go and explore. All right, going back to the continue statement. The continue statement, I think, is even more like, I'm not saying it's like useless, but you can always come up with some other logic to kind of not use continue statement. What this does is essentially, whenever your code encounters continue, right, it's going to like skip over whatever is like the rest of the code after the continue statement. And so, of course, you can tell that you can always have something, and let me show you this example, what it does. Okay. All right, so I have like 4 item, and let me create some my list. Okay, let's say my list has like 1, 2, 3, maybe -5, -6, 0, I don't know. Okay, what we're trying to do here is that if like my code encounters a negative, so like this, if my code encounters like anything, any negative number, then I should be able to like skip that essentially, right? And you can tell, you can like, even without that continue, you could have like easily achieved that. Or maybe I want to print the items that are like not less than, because what this continue is doing, and that's what the lecture notes also explain, is that like this immediately goes back to the next iteration and it skips the rest of the code within that iteration. Yeah, that's like a better way of putting it. So the current iteration, everything below that will be skipped. Let's see what's going on here. So in my current iteration, I have an if statement and I have a print statement, right? So this, like, whenever my code is going to see this continue, it's going to skip this print statement. That's all there is to this continue. Let's see. So this like skipped the rest of it, so it didn't print that item, right? And as I said, both the break and the continue statements are these like alternate tools that you might use. But there is always some logic that exists using which you can like have the same effect as the break or the continue, especially continue. So I've seen people using continue a lot, and sometimes it's just like useless. And you'll see in an example today that there is no use using that statement right there. Let me show you that example. All right, so here what we are doing is like we have these grades, and we're trying to sum up the elements in there and just like counting the grades that are greater than 0, right? So if I do this like for grade in grades, right, and just have this like if statement and not have the rest of this, right, not have the else, do you think it's going to like produce the same output as it is producing now? You got my question right. Yeah, excellent. Yes. So it is going to, because you know how if works, right? It is going to add this only if like my grade is greater than 0. Otherwise, it won't anyways do anything, right? So there is no need to do an else continue, because here like the intention was, if this does not happen, then just like skip the iteration of the loop, which anyways this is going to do, because there isn't anything ahead of that. However, if you have something that like if a certain condition happens and then there is more code below this if, let's say some more complex code is there which you don't want executed within that like iteration, you can definitely use continue, because continue is going to just like skip and go to the next iteration of the for loop. All right, so that was about break and continue, and let's move on to the termination of a while loop. This is an important, like very important topic, because while loops are infinite, as we just saw. I saw questions. They just disappear for some reason. John, your question is, will we ever lose points on something for having useless, unnecessary code? Not really. We don't take off points on having like something that's extra. So I wouldn't say yes, especially not on exams. And on homeworks, like we've started to look at the structure of the code, but not really like something that's unnecessary. I mean, it can slow down your code at some point, which we haven't covered yet, but we'll talk about the like code efficiency and all of that. So if you're talking like in terms of continue and break statements, it's totally up to you if you want to use them or you don't want to use them. So like, I'm not saying that using them will make you lose points. So Caesar, your question is, can you explain, continue from the first example again? Yeah, of course. I think we have time. Let's go back. So here, this is the first example, right? This is the one you're talking about? Okay. Yeah, so here I have a list that has like both positive and negative numbers, and I just want the positive numbers to be printed. And for that, I'm using the continue statements such that whenever the item or like any of the numbers in the list is a negative number, I want it to continue, which means just like skip the rest of the code below continue and just go in and take the next iteration, right? So this is what it does then. Like if I execute this, this print is not like this. This print is not executed whenever it encounters like the negative numbers, because anything below continue is not executed. Okay, that's great. Let's move on to the termination of the while loops. Okay, so in this example, and let me actually, and there is like an additional flush equals true that we are looking at, and I'll talk through that as well. Yeah. Now we said that while loops are like infinite, and especially like if they have some condition that can become true, that can become false only in certain situations, this can become an infinite loop. So let's see what's happening here. We read a user input, essentially a number, and that number could be any size. And what we are saying is as long as that number stays greater than 1, right, keep finding like the square root of that number and keep printing it, right? And you can imagine like this is a user input number, and it could take any value, any big value, right? So this loop can go on for so many iterations. And so that's like one way to handle that, which you can tell it is going to take up a lot of your memory. It is going to take a lot of your runtime. And so the like one way to deal with such a situation when your like loop is creating a lot of data is to set this parameter in the print statement flush equals true, right? So it is going to clear the buffer for output. And of course, it's an optional parameter, but sometimes it's useful when you know that your code is generating a lot of data, which is like in this case, because you don't know what somebody is going to like uh, enter here as a number, right? So if you're doing that, like if you're dealing with any such problem wherein you see that like your loop is taking more than um, normal time, it's a good practice to just go and do flush equals true, because then that's going to like clear the buffers like every certain amount of time after every like few seconds or few minutes, and that's going to help run the code. So that's one thing. And the other thing is like, of course, this is an infinite loop, because you can tell this keeps finding the square root of a number until it becomes 1. Let me see what this does. And you can tell this is going to take a lot of, I don't want this. All right, so here, even if I enter a number like, let's say 9, you can see how many iterations went. It went into, because like once I am at like 3, right? It takes like so many iterations to come down to like exactly 1. And this was only for number 9. So you can imagine like if we have a bigger integer, and if you encounter such a situation, you know that it's taking up a lot of your runtime memory, and you might even get like runtime errors for these kind of cases when you're using like this infinite loop. So that's why we have like this print flush equals true. All right. Questions, doubts? Okay, I have a question for everyone. If I, instead of like saying while x greater than 1, if I'm saying if x greater than equal to 1, do you see any issue here, or like, do you think it's going to run okay? Rochelle, you're saying finite. No, it's an infinite loop. Yes. And why do you think it's going to go into an infinite loop? That's because this 1 is going to stay forever. We just saw that it eventually comes down to 1, and the square root of 1 is 1. And so, yeah, that's correct. Whoever is saying it's like, yeah, the square root of 1 is 1. And so this is going to go on forever. So a slight change in my condition can lead me to like this infinite loop. This points us to the fact that if you're using while loops and you have a condition, and sometimes you even have like more complex conditions, which I've seen you'll be required to use in some of the homeworks that are coming up, make sure that this one goes false at some point. Because like just by adding that equal to sign, this is never going to go false. And this loop is going to go on forever. Right? And so this is what this part talks about. Here my while loops runs forever and it never stops. And maybe we can have like a break statement, or maybe we can have like some ways of controlling it. But the first and the foremost thing is to check your condition, because it's like mostly the condition that's making it like run forever. All right, so that's okay. These are questions. What does flush do again? So in the print statement, let me show you. Like in the usual print statement, you have like these arguments that we like, some of them we are familiar with. This is like another parameter that we are using. By default, it's flush equals false. That means it is able to internally handle some kind of like some finite memory. But in cases like this, like when my while loop is generating so much data and so much output, it's a good convention to turn this flag like flush equals false to flush equals true, because this is going to clear the buffer for your like standard output, because it can just like generate a finite amount of output at like one point. So that's what it does. Whenever you're like using a while loop and you know that it's going to generate like too much output, it's good that you can use just like flush equals true. And yeah. Okay, so all right, let me go back to the lecture notes and see if we covered everything. Talked about continue and break, and yeah, I think that's it for today's lecture. In summary, I'd like to like summarize, try to like go and do more experiments with the control statements, especially when you're using for with the range function, because that is going to be extremely useful, like solving more than half of the problems that are coming up. So try like practicing that. And then we looked at the nested for loops and how like to iterate over two-dimensional data, and also like how to use loops with lists, especially lists of lists. And this is going to become like more of a norm going forward, that we'll be working with lists of lists and do something with that. So now you know how to access that, how you can use functions on them, and so on. And finally, we learned about like these control statements, the break and the continue with the while loop. And as I said, like these shouldn't be used too much, because sometimes in your like extremely complex code, you're using too many break statements. It becomes almost impossible to track down where exactly your code is stopping. And so if you have, and there is always like another way to handle a break or a continue logic. There's always another way. And so that's why we like a word of caution, whenever you're using them, like try to use them as less as you can, or like unless you're 100% confident what it's going to do, just try avoiding it, I would say. All right, so that's it for today's lecture. If you have questions, you can stay back. Otherwise, thank you, everyone. Thank you for joining. That's it from my end. Thank you, everyone.